Assalamu alaikum, dear students. In this lecture, we will be discussing the value of the determinant using the concept of cofactors. You know that we can calculate the value of the determinant by simply expanding that determinant, the first method. The next method is by using the properties. And the third method, that is by using the cofactor concept. So, uh, how can we do that? Here's a remark. You can see this remark. I would like to highlight the conclusion of this remark. That is, value of the determinant, any determinant, is equal to sum of product of elements of any row or column with their corresponding cofactors. Okay, so you have to see the value of the determinant. You multiply the elements with their corresponding cofactors of any row or column. You will get the value of the determinant. So on this concept, we have some questions in your exercise, and it's question number 3. Using cofactors of elements of second row, evaluate this determinant. So second row is this. So we have to find the cofactor of 2, cofactor of 0, cofactor of 1. We have to multiply their corresponding cofactors with these elements, and sum of these, the value that we will obtain, that will be equal to the value of the determinant. So how can we do that? Here is the solution. It's question number 3. I have solved it here. You can see it here. So this is question number 3. We are given here this determinant. So we will see the second row. The second row has the elements. First element is 2. Its position is 2, 1. So minor 2, 1 is calculated to be equal to minus 7. Now cofactor, that's equal to minor with proper sign, that's equal to 7. Similarly, the minor of 0, that's M22. 0 is at 2, 2 position. So its minor is equal to 7. Its cofactor is equal to minus 7. Okay, so similarly, you can find uh, minor of 2, 3 element. 2, 3 element we have here 1. So minor of this 1, that is equal to 7, and its cofactor is equal to minus 7. If we will multiply the elements with their corresponding cofactors, what we will get? We get it like this. Element with their corresponding cofactors, element with its cofactor, element multiplied to its cofactor, element multiplied to its cofactor, adding all the three. So you get 2 into 7 plus 0 into 7 plus 1 into minus 7, you get 14 minus 7, that's equal to 7. So this is the value of the determinant, and we have calculated it using the concept of the cofactors. On the same lines, we can solve this question number 4. The solution is here. I have solved it. You can see this. So you see it like this, and at the end you see that the question actually says you using the cofactors of the third column. So third column is this: yz, zx, xy. We have to find the cofactors of these elements, and we have to multiply the cofactors with these elements, and we will find the value. So here is the element, this is the given element, this is its cofactor, element multiplied its cofactor, element multiplied its cofactor. So what we get, that is here. Solving these, making the necessary calculations, we arrived at the last step, that is value of the determinant. Value of the determinant we have here, that is del is equal to x minus y, y minus z, z minus x. So this is the way you can solve the questions based on these. Okay, so the next question here in this is question number 5. It is, if del is equal to this and aij is a cofactor of aij element, then a value of del is equal to. So there should be a correspondence of the multiplication and then adding the quantities, we will get the value of the determinant. That means if you see here in the first part, it is a11 multiplied to a31. No, this way we cannot calculate it. It's a11, a11, a12, it's a21. No, it's a21, a1. No, it's not. It's a11, a11, a21, a21, a31, a3. Yes, it's correct. Part number D is the correct option. Why? Because here the elements of the first row are multiplied to their corresponding cofactors. So this way, this is actually the remark that we have earlier highlighted. So the correct option is part number 3 of this question. Thank you for joining the class.